Hey, thank you for having me. Again, I'm a developer, so not really a business person, or I guess it depends on how you think about it. But the question is, after we've seen all the sophistication that some big companies have in their organizations, the level of detail that they look at and the way they aggregate data from multiple sources, the question is, how do sort of smaller businesses go about doing that? What's actually running underneath? How do you set up, sort of a lab in which you can do this sort of analysis, technically? This is what my talking is going to be about. Before I do get started, who can tell me, are you guys sort of enterprise architects who thinks about himself as being an architect? All right. Who's a purely business person, results driven? All right. Who's a developer? All right. The majority of you are business folks, but so this talk is going to be a little bit more technical, but I think you'll be able to follow. So again, I'm been involved in sort of building products for some time now, and as a developer, I sort of see a lot of patterns around, and I'm gonna talk a bit more about what I see happening in a lot of the companies that I'm working with. So we're gonna cover, why we see this trend of building a data lab and a data exploration team, happening, and how that can be done in the cloud of all places. I'm trying to sort of answer the big elephant in the room sort of question, which is about security, and how you can integrate the two realms, the cloud and the on-premise, in a secure way. Because it's not trivial, but it's certainly not impossible. So we have to cover that as well. And then we're going to sort of present the solutions, off-the-shelf solutions which are out there. So this is not a Bigstep specific talk. It's more of a general one. Right. So data exploration. This is what I call the actual action of trying to sift through a lot of data, and is done within organizations by many people. It's not a single group necessarily, called the data explorers or the data exploration group necessarily. It's rather done in various departments by various people. So it's either more advanced sort of data science done by data scientists and very, very smart guys. Very few of them are actually like that. But also more what other people call the citizen data scientists, which are not specifically trained for doing that, but they have picked up a few techniques. And it goes all the way down to like executives playing around with a visual dashboard like Zoom data or something like that. So data exploration is actually done by a lot of people in organizations. And as I said, I like to call this group the data exploration group. And the pattern that I see recently in the last few years is around the fact that if previously we've seen this happening in sort of the marketing research group or more operational group, whereas this was a more a task that was focused on creating dashboards and reports and graphs for business people to take decisions from. The data exploration group has a different meaning, has a lot more independence. It typically reports directly to the CEO, and its purpose is to interpret data, not just generate the actual graph. So it doesn't deliver a graph. It doesn't deliver sort of a dashboard. What it does, it delivers. Of course, it delivers some data, but it delivers it by telling a story. And one of these sort of stories, to give you an example, is what the sort of data exploration group at Unilever has done recently, I think this year. They've done this study, humongous study, and they come up with a single phrase that describes what the study sort of talks about. And it is about the fact that consumers are now focusing on local brands. And they tie their identity with the identity of the brands that they're consuming. So Unilever is now shifting their strategy to promote local stuff rather than sort of global Coca-Cola level brands. This is the sort of story that this group has to be able to tell executives, right? Okay, so what do you need to build this team, and what does this team need to do their job? So one of the concepts that you have seen popping up all over recently is the concept of a data lake. Who knows what a data lake is? I mean, I'm assuming you guys know, all right? For those of you who don't, basically a data lake is a place where you aggregate data from a lot of sources. Now, these sources, people talk about the sources from different silos within an organization, and you bring them and you put in one place, like one giant database. But for me, what I've seen more recently is that the value is in getting data from external sources. So we have a customer that has data in Salesforce, has data in Marketo, has data in something called InfiniCloud. They're sort of IVR as a service, and they have data in several other sort of external SaaS services. And so how do you do an analysis when the data is outside of your organization? So what you want to do is you want to sort of use the APIs of the respective services and bring all that data through the APIs in whatever format they might be stored in those respective clouds into your organization, so you can do that analysis. And that data is not structured, right? So for InfiniCloud, for instance, they have a bunch of JSONs. And so how do you got to have an environment where you have to be able to do sort of structured and unstructured queries at the same time. So this is what building data lakes means. And the technology for doing that, I can cover them if you like, but most of Hadoop environments allow you to build this sort of data lake. But the data lake is just the storage part. The more complicated part comes with the actual software that sits on top of the storage. So what do you want to run? And to answer that question, you got to look at who uses that data. So who are the users of this sort of data lab that now, as sort of architects we're building. And there are two main users. One of the sort of data scientist user, which can run a little bit, can write a little bit of code. But there's also the business analyst, or the BI, if you like, in the particular organization. They do data exploration. They look at the same set of data sets, but they use different tools. The data scientists can run, can use Jupyter or Zeppelin or notebook technology, or even write Spark jobs. But the business analyst has to look at more sort of exploratory tools like Zoom data and some other visualization tools. But they all have to use the same compute infrastructure, right? So they have to coexist from a compute point of view and have to coexist from a storage point of view. So basically, they want to consume these compute and storage resources at the same time from a sort of common pool of resources, but at the same time, the technologies that they use are very different. So the traditional Hadoop stack is more of a, monolithic sort of thing, in the sense that it runs as a single stack, and you gotta be able to install all sorts of applications on top of that. Is gonna be really complicated. So, my suggestion is going to be about breaking these things up, and I'm going to show you a few architectures later on about how we do that. But the idea is storage nowadays is cheap. It's so cheap, in fact, that you can store a terabyte with $36 per month, which is so cheap. So you can afford to store multiple copies of the same data. Compute, on the other hand, is not that cheap. It keeps on sort of being at the same level. It gets better and better, but it's not dramatically, increasing in terms of how much it costs. And so it's good that you can scale storage a lot. You can do a lot more if you can store multiple copies of the same data, and you can store everything, and it's cheaply and freely available. So I would always encourage you building that separation between the two if you can. So why the cloud? Because of course you can build this sort of data lab on premise, and it might be easier, but why the cloud? And this is a study that was done very recently about what the problems are in moving into the cloud, because enterprises want to move into the cloud. They understand that it's a need, for flexibility. But the biggest problem seemed to be lack of expertise and the problem of security. But what's apparent in this graph is that the trends have reversed. Whereas last year it used to be security the #1 problem, now it's lack of skills. So the biggest challenge is actually finding people to do this sort of thing. And security is not as much of a concern, but still, number 2 is still good. So how do you address the first problem, the lack of skills? And the lack of skills is a complicated matter because you can, it's hard to hire people. Everybody's looking for data scientists and these unicorns. So one way of solving this skills issue is to sort of hire software instead of hiring people. And getting the right software in, is what's important. But how do you choose what's important? You cannot do a gazillion POCs at the same time. So what I suggest is experimenting with different technologies. I'm going to show you exactly how. And the second of all, how do you assure the security of what's running in the cloud? And for the security part, and the big elephant in the room, if you build a data lake in the cloud, right, it's a honeypot. It's a target for all the hackers in the world. Recently, we have had a lot of advances in how we can tackle this problem, and we can do it in the cloud as well. And there's a recent trend with bare metal clouds. I'm going to talk a bit more about it, but there's also a lot of ways to do security in the cloud that's very similar to the level of security that you have on premise by using encryption, by using federated Kerberos and Active Directory. There's a lot of things that you can do to sort of get to the same level of security that you have on premise, but also get the benefits of the cloud. So, bare metal cloud providers. You've seen a recent push from Oracle on this side. The Oracle bare metal cloud is that they are called the second generation bare metal clouds, and the purpose is to have a bare metal infrastructure that's able to come up and down immediately, right? The same level of sort of flexibility that you get from AWS. The advantage of that for security is that it's single tenant, and it runs it within a sort of, it's single tenant, it's isolated. So it looks and feels like it's your own data center, but it comes from an infinite pool of resources, the sort of infinite pool of compute and storage that we need to build this data lake, this data lab. All right, now, this is a screenshot of a study of the output of a security tool that I've installed at one point on one of our servers. It's called Metron, Apache Metron. I have heard about them. What they do is they look at all the data that comes into a server, like PCAP data, just packets that arrive to a particular server, and then we've mapped this over a map. And what you can see, this server has been on the internet for 2 hours. So it was a brand new server, didn't do anything. The only objective of that server was to see what happens. And this is what it happens. Basically, the server was in Germany, so that's why Germany is really increased. But everything else is just like random port scans from all places. So we, apparently, people in South America do a lot of scans. So the internet is kind of the badlands right now. So you cannot just simply have things on the internet. So how do you secure them? How do you take your servers off the internet but still consume, the cloud? And there's of course something like the VPC of Amazon, where you connect through a VPN, and this is the first solution. And it works great for a lot of people, not so great necessarily for big data, because of the actual sheer volume of traffic between the two endpoints. You have to go through this VPN concentrator all the time, which is, it's very secure, but it's also a bottleneck and a single point of failure. You can sort of make it highly available, but then that complicates your infrastructure as well. But we've seen this, many times. Another way of doing it is what I call the targeted firewall sort of configuration, where you have a firewall in the cloud and a firewall locally, and SSL communication between the two. And this only allows traffic from a trusted source. And the traffic is encrypted. So it has sort of the same level of, it solves the same problem, but it allows every node to talk to every other node, and there's no single point of failure, and you have also the entire bandwidth that you can use available. The second problem was, okay, you cannot have good security without using the sort of identity services, right? So you want to make sure that you correctly identify who's talking to the cloud, right? How do you do that? People ask typically, how I run ID in my on-premise, how do I use that ID services in the cloud? And there's a way to do that. Basically have the cloud services, use the AD on-premise. Well, you can do that. It's not optimal because there's a lot of traffic going on between your applications and the ID on the identity services. So a better way of doing that is running a sort of a mini AD in the cloud and having a trust relationship between that AD and the AD that's on-premise. And you can actually build this pretty easily. It's not that complicated. I won't get into the details, what it's actually doing there. That's a talk for another time. Okay, secondly, what you can do is you can join single sign-on domains. So you have single sign-on domains on-premise, sort of corporate thing. You can have it in the cloud as well. It can work very well. You can integrate it too. Again, I can get into more details if you like, but basically it works exactly the same. This isn't a big performance problem. Then there's encryption. There was a keynote. I forgot the name of the presentation, but it was about tokenizing the data. Tokenization is one way of doing it. The other way is using encryption, and encryption using a KMS or an HSM that stores the data. And there is a way of storing just the master decryption keys on premise in an HSM, and using that HSM that's on premise to sort of just hand over some keys in the cloud and have the cloud use the keys temporarily to decrypt and encrypt data without ever having the actual keys. So everything's stored in memory. So this is actually, there's a vendor that can do that, actually a couple of them. It can be done. Okay, what else? You need fine-grained access control. Both Kerberos and HDFS allow you to do this. I won't get into too much details, but the point is there is a way with just regular HDFS to control who has access to which file in which specific time and why. Again, I'm talking about HDFS because that's typically what's used for building data lakes. And not a lot of people know that they can add, besides the POSIX permissions, there's also ACLs that you can add. So those allow people to specify a particular rule for a particular person for a particular file. So it can get really down. Okay. Now, in terms of actual compute, my suggestion has always been to sort of reduce the number of technologies that you use for compute itself. So sort of use a single unified compute platform, but have multiple endpoints to it and multiple users of that. And more recently, we've seen Spark being used as opposed to MapReduce. And what might not be really apparent from this graph is that Spark, and more specifically Spark SQL, by using a specialized file formats, acts as a database. And for certain workloads, for certain things, for mostly exploratory sort of analytics, it can work very well. We've seen that it's actually quite fast. If you have a bunch of analytic tools like Qlik or Tableau, you can connect them to Spark SQL, and them in turn can store data directly in HDFS in a specialized file format. These specialized file formats that I'm talking about, called the Avros and the Parquet file formats, they store both the data and the structure in a particular file. And they're optimized for doing parallel stuff with that particular data. And it can scale very well. And again, it acts as a database, but at the same time, it can work with unstructured data. Avro is designed for unstructured data. So the same set of queries can be run on unstructured data as well using Spark. It's a sort of a unified compute platform that we can use nowadays. And more specifically, I've talked about that decoupling between the storage and compute. I have 3 minutes left, so I'm going to rush a little bit. But this is the architecture that I've seen being deployed more recently. It's a container-based architecture. By the way, you're going to see more on containers from all the major Hadoop distributions out there next year, in the sense that you have a single unified compute environment, but you want to be able to spin up containers with specific applications within that particular compute environment. So what I have here is both Zoom data, Jupyter, and Kafka running as containers on the same platform. If you haven't used containers, containers are good for not wasting your compute resources. They are very efficient. They run at bare metal speeds, but at the same time, they allow you to sort of, if you delete a container, you delete all the dependencies of a particular application. So it's a lot better to install an application, or in fact multiple versions of the same application in containers rather than directly on the hosts, because you can rip and replace all the time. So you can experiment with technologies just as much as you experiment with data. So you need this environment to have this data, this technology experimentation and data experimentation, data exploration abilities within a single sort of unified place. And this is typically decoupled from the HDFS underlying layer. It doesn't necessarily mean being on different machines. It can be on the same machines. It's also about the separation of concerns, if you like, and the ability to scale both. So you can have a lot of machines that have local drives, also a lot more machines that have just compute, or vice versa, depending on what you want to do. Real-time is another sort of thing that we've seen happening a lot recently. It's a lot of, what I've seen is that many times when something works as a batch, if something works as a batch, somebody's going to ask, okay, how fast can you do it? And this sort of transforms into a real-time thing. But real-time are production environments, completely different than batch processing environments, because they have to be maintained, they have to be kept alive. So what I'm saying is that even though they look the same, they do the same things, they work on the same data, they're in fact production environment. They should be sort of separated from these things. But you can build for sure like experimental real-time infrastructures on something like a data lake. So I'm wrapping up. This is the last slide. Some of the vendors that you guys can use to build something like this, talk to your colleagues. There are bare metal clouds out there, more than you would think. Second generation bare metal clouds. There's software vendors like Blue Data who can give you like the container management platform specifically designed for doing big data. There's Bigstep, of course. There's Google Data ProxSpark. They have a product called the Data Lab specifically. Azure as well. The idea is you have the vendors out there. You can just start exploring this idea of putting together this environment to do data exploration and technology experimentation, and maybe gathering that group together and start building these sort of capabilities in your organization. And that's it. Any questions? Do we still have time for questions? Sorry. One or two minutes. Okay. There's one question there. The mic is coming.
Thanks, Alice. That was great. And I have heard the argument that full bare metal server is faster than virtual machines, but virtual machines cost less, so you can, just get more virtual machines, and you will get the same performance, maybe at a lower price. What do you think?
So the question is, if VMs cost less, why don't you get more VMs? And it depends on what you do with the VMs. If you use like 100% CPU utilization, VMs cannot cost less because they use the same CPUs. Physically, it's not possible. So it depends on your workload. VMs cost less if you have many of them sharing the same host, then you have CPU utilization, sort of at an average of 50% or something like that. So you gain by over provisioning. But in the case of sort of big data workloads, that's not always the case. Sometimes you have 100%, sometimes. More often than not, you have 100% CPU utilization. So the ability to do consolidation in these sort of environments is less than like web-based applications. So also bare metal typically comes with so in these scenarios, bare metal sort of gives you at least 50% performance increase. So for that, sort of the same money, you get 50% more performance, and you cannot do the same things with VMs at that price level. So economically, it's actually a lot cheaper to do it on bare metal. So, but we can get into more details if you like. But that's the general rule. Okay. Any other questions? We don't have time. Okay. So thank you very much.